In this video, we'll balance the net ionic equation for KNO3 plus Na3PO4, potassium nitrate plus sodium phosphate. So the first thing we need to do with net ionic equations, we need to balance the molecular equation. I have 3 sodium atoms here and just 1 here. I'm going to put a 3 here. That gives me 3 sodiums. They're balanced, 3 nitrates. Might as well put a 3 in front of the KNO3. So now I have 3 nitrates here and 3 nitrates here. 3 potassium atoms, 3 potassium atoms, and a phosphate and a phosphate. This is the balanced molecular equation. Now we can write the state for each substance. If you know your solubility rules, potassium compounds and compounds with this nitrate ion here, very soluble. So we'll put an AQ there to show that it's aqueous, dissolved in water, and splits up into its ions. Sodium compounds also very soluble, even though in general phosphates aren't soluble. If you have sodium phosphate or potassium phosphate, group 1 elements, that will be soluble. Here we have potassium phosphate, that's in group 1, so that would be soluble. And then we have another nitrate with a sodium compound, that's going to be aqueous. At this point, everything's aqueous. That means that there's no reaction. If we wrote all the ions out for these compounds, we'd see that in the reactants here, we have the same ions as we have in the products. They're exactly the same. So nothing's changed, so no chemical reaction. With net ionic equations, we cross out spectator ions. So if we cross the spectator ions out, we'd cross these potassiums out, we'd cross the 3 nitrate out, cross the 3 sodium ions, then we cross the phosphate ion out. Everything crossed out, so everything's a spectator ion. No reaction. There'll be no precipitate forming in the reaction of KNO3 plus Na3PO4. Nothing's changed. No reaction. This is Dr. B with the balanced net ionic equation for KNO3 plus Na3PO4, where there really isn't any reaction. Thanks for watching.